All right, so we're going to start with some flight planning. So we finished up with sectional charts last time, and so today we're going to start using sectional charts to plan our flights. So today, just going to walk through an example um, of how you'd do a flight plan, what to look for, what to calculate, um, and it's just going to be a real basic flight plan. So nothing too crazy, and should get the main idea across, hopefully. Um, so first things first, um, I'm going to pick an airport as our starting point. I'm going to choose Grand Rapids just for simplicity's sake, and because I think that the route is going to be pretty nice for first flight plan here. So we're going to go ahead and pick Grand Rapids. We're going to be flying up to this airport up here, Robin Hood. And so it should be a pretty straight shot. We're just going to go direct from Grand Rapids to Robin Hood, and yeah, should be pretty easy. So one thing we haven't talked about yet is this thing over here, this navigational log. So these are handy for planning a VFR flight plan. In all reality, though, if you go beyond the stage where you pass your check ride, this is pretty much all electronic these days. So knowing how to do this really is kind of one of those things that you do once and you pass your check ride and you pass your written exam, and then you never really need again. So fortunately, it's just something you have to learn because this is what they test you on. But beyond that, they have computers that do this, iPad apps, FlightAware, or not FlightAware. I can't remember the name. But anyway, they have iPad apps and they have all kinds of stuff online that you can do this. Even SkyVector can do flight planning. So yeah, this is not necessarily something that is realistic, but unfortunately, you need to know. So yeah, we're going to use this navigational log, and that'll help us keep track of our route, our navigational aids, altitude, wind, all this stuff. And we'll fill this out as we go along, and I'll explain what each column is and what it does and what we need to know from it. So first things first, we're going to put our checkpoints in. So we're going to be taking off from Grand Rapids, and that's going to be our first checkpoint. So I'll put KGRR, which is the ICAO name for Grand Rapids. And let me real quick put in Grand Rapids on SkyVector as well, and we'll get a little line here. Our Owasso is RQB. I'll put Owasso in KRQB. And SkyVector will plot this nice little line here. So one of the things we want to do in flight planning is we want to pick checkpoints along our route. At least in VFR flight planning, when we're flying visually, we want to pick things that we can see. Now, how far apart you pick these things, what things you pick, those are all kind of up to your personal preference. In this case, I think if we had 2 or maybe 3 along this route, that'd be perfectly fine. 1 might be not enough. 4 or 5 might be too many. Just might be too much to do. So I think 2 or 3 would be a good number. The one thing you want to keep in mind with VFR flight planning and picking checkpoints in particular is that the idea here is you pick a checkpoint so that you can verify that you're on course and that you're burning the right amount of fuel, that your speed's right, that your altitude's right, that you're not off track. If you don't pick any checkpoints or waypoints, then you might end up at your destination. You might be 20 or 30 miles off because you didn't correct for some amount of wind that picked up or something that was different. I don't know, you just missed something because you weren't doing checks, or you ran out of gas because you're burning more than you thought you were, something like that. So checkpoints are handy just to keep you on track, make sure that everything is normal. So we want to pick stuff at regular intervals, and we want to pick probably 2 or 3. So For this route, we have a lot of options. So a lot of things can be checkpoints. Cities can be checkpoints. Airports can be checkpoints. Towers, if they're big enough, could be a checkpoint, depending on what it is. Roads, if they're like major highways, things like that. Rivers could be checkpoints. However, at night, those might be harder to find. So during the day, maybe. During the night, probably not. Even still during the day, sometimes it's hard to see rivers because they're kind of dark. They kind of look like the ground. I mean, might be hidden by trees. I don't know. So rivers maybe, but cities definitely are good if they're the right size. Like picking Grand Rapids, for instance, would not be good because there's no way that you could checkpoint Grand Rapids like, oh yes, I'm flying over Grand Rapids. Well, there's a lot of places you could be flying over Grand Rapids, so that's not a good checkpoint. But smaller cities like Greenville, Howard City, those are good checkpoints. Major highways, so we have 131 that runs up through there. That's a major highway. That'd be a good checkpoint flying over that. Airports, now if we wanted to change our route, we could also kind of zigzag up here. We could kind of go over some other airports like Lakeview or Greenville or one of those other smaller airports, and we could do use those as checkpoints. That would work fine as well. Another thing we can use as checkpoints is we can use VORs or nav aids. So we have the Muskegon VOR, the White Cloud VOR, and the Victory VOR. And in fact, we also have the Mount Pleasant VOR over here. And so if we wanted to, we could pick one of those VORs and we could triangulate our position against something we know on the ground, or we could triangulate our position with two VORs if we had two VOR receivers in our aircraft. So we could get a VOR radial off White Cloud and a VOR radial off Muskegon, and we know when we're on both those radials that we are at a certain point. And so that's another thing you can do for VFR flight planning. So for this route, I think we could pick maybe some simple checkpoints. So maybe we'll pick Cedar Springs here and Howard City. And we'll use those two cities as our checkpoints. And maybe we'll also note that Cedar Springs has a certain radial off of Muskegon. So we know that when we cross that radial from Muskegon's VOR, that we are indeed over Cedar Springs and not some other city. That doesn't happen to be any other cities around here, but we can triangulate that position like that. So we'll pick Cedar Springs and we'll pick some radial off this Muskegon VOR. And then at Howard City, it looks like we cross US 131 there as well. So we'll say that whenever we cross US 131, that and we also see Howard City off to our right, that will be our second checkpoint. And we'll just use those two for now, just to keep it simple. So put in our flight plan over here, our checkpoints. So we'll put Cedar Springs. And we'll also put Howard City in here. And then for Cedar Springs, we're going to use the Muskegon VOR to cross-check that position. And so what we can do is we can use this nav aid column here. And so the identifier for this VOR is going to be on this VOR box. And so we have the VOR box here, which is the Muskegon VOR. And we see that the identifier is MKG. So we'll go over here and we'll type MKG as our identifier. And we'll see that the frequency it uses is going to be 115.2. And so we'll also type 115.2 as our frequency. And so we know that when we are crossing near Cedar Springs, we can dial in or have this dialed in already. And that's the VOR that we want to check. So yeah, we'll use that. Now, as far as what radial to use, this is one of the things that's hard to do online because I don't have a plotter for my sectional chart. However, you can look up tutorials online. In fact, I might send out a few videos on how to use a plotter to get the actual radial off of this VOR. But for now, we're going to kind of guesstimate what the radial is. So we have here 0 through 90 degrees and then 90 through 180. And so what we're going to do, we're going to look, we're going to see that Cedar Springs is probably, in fact, let's do this real quick. We're going to go from Muskegon. If I can put a, maybe I can't drop, I thought I could drop a pin there. Oh, well. We'll just kind of guess, I guess. Okay, so Cedar Springs here, Muskegon VOR over here. And it looks like maybe this is like 70 degrees, so 70, 80. It's probably pretty close to 80, maybe 82 degrees. So we'll call it 82 degrees off the Muskegon VOR. So we know if we have radial 082 tuned in the Muskegon VOR, that we should be hitting that radial dead on. We should be right on that radial crossing over Cedar Springs. So we'll add a little note in here. Cedar Springs MKG VOR is equal to 082. degrees. So Cedar Springs, Muskegon VOR is going to be 082. You can do whatever kind of shorthand you want there, but that's where we put that. So we know that when we're crossing Cedar Springs, we'll be on that 082 degree radial. So that'll be our first checkpoint, and then our Howard City checkpoint will be up here, and we know that we're also going to be crossing the road, US 131 there as well. So we'll keep that in mind. So the next thing we have to do is we have to get our course route. So this is one of those things that, again, you do with a plotter, and unfortunately I cannot use a plotter digitally. I tried to find something online that would support it, but does not seem to be anything. So I'll try and send out videos of how to do this with a plotter, but for now, we're just going to assume that we've done that calculation. We've gotten our line, which goes between our two destinations, and we have done the necessary things to get our route length and our heading. So that's what this line, this pink line here represents. So we have it's telling us that if we fly from Grand Rapids to Robin Hood, it's going to be a 007 degree direction. This is a true heading, not a magnetic heading. Actually, we'll just put 7 in there. So 7 degrees. And that'll be true for both of our checkpoints here. And so we'll put 7 degrees in for our heading or our course route here, since we're flying on that straight line. Now, the next thing we have to do is we have to figure out what altitude we want to fly at. So we talked a little bit about this in the regulations section, I think. If we're flying above 3,000 feet and we are on a heading of from 0 to 179 degrees, it's going to be odds plus 500 feet. This is VFR cruising altitude regulations. And then if we're on heading 180 to 359 degrees, it's going to be evens plus 500 feet. And so we will get our heading here. And so since we're on, I think I should also mention that that heading or that altitude is in mean sea level. So you have to adjust for that as well. But we'll assume that we're going to be cruising at that altitude anyway. So first, let's kind of pick an altitude height that we kind of want to be in a ballpark of. We probably want to be above 3,000 feet. But let's say maybe somewhere between, or let's go less than 8,000 feet. I don't know, somewhere in there. So maybe 3,000, 8,000. Let's see. We're on a 007 degree heading. So that is going to be odds plus 500. And we want to probably pick something like 5,000. So 5,000 plus 500 feet. That'd probably be a good cruising altitude. So that's going to be, we're going to put that in for our altitude. So we're going to pick 5,500 feet, which is our odd altitude plus 500. And we'll also put that in here. Oops. So that'll be our VFR cruising altitude, 5,500 feet. And so, yeah, we'll pick those. So we'll pick 7 degrees for our course route and 5,500 feet for our altitude. Next, we have to get winds. So for this, we can go over to our Aviation Weather Center and we can get the wind forecast. So the winds are going to be under forecasts and then under winds and temps. Now what we have to go to is down here, and we're going to click on this region, which will have all these little airports in there. And then we have to look at this huge bank of data from all the airports and all the elevations. And we have to get our winds for our flight plan. Now, this product is going to have different use times and different products, but we're just going to assume that we're departing like soon, like now. So we're just going to look at the most recent 20 Zulu to 03 Zulu. And then what we're going to do is we're going to find the closest airport to our flight plan. And so the closest airport that happens to have this information is going to be Muskegon, so MKG. So we're going to go down here on the side, look for MKG. Once we found it, we're going to go over and we're going to pick our altitude that's closest to our flight planned altitude. So we're cruising at 5,500 feet, and we're going to choose 6,000 here. So at 6,000 feet, we can see the winds are going to be 350 degrees at 07 knots. And then the temperature is -5 Celsius. And so what we can do is we can go over here and we can plug those in. So wind is going to be, what did I say, 350, or no, yeah, 350. And then the velocity is going to be 7 knots. And then our temp is going to be -5 Celsius. Put that right there. All right, so we have our wind direction and our wind velocity. So 350 at 7 knots, and our temperature is -5. We can also put that down here in this box. So now that we have that information, we can get our cruising airspeed, which we're going to assume that we're flying in a Cessna, let's say a Cessna 172. And off the top of my head, the cruising speed that we normally use is going to be 115 knots. This number usually works for our flight planning calculations, and this number can be looked up in the handbook for the aircraft. But for now, just have to trust me that this number works out. So yeah, you can look it up in the Cessna POH, but we're going to use 115 as our true airspeed. And so that's what this column is, TAS, true airspeed. So for our true airspeed, we're going to pick 115. So that's what we'll put in there. That's 115 knots. All right, so now that we have all this data filled in, we can start to get our headings and our courses. So we actually have to do some calculations now. So we have to figure out what our true course is going to be. So in order to figure out our true course, we have to have our course route, which is our 7 degrees here. And then what we're going to do is we're going to apply a wind correction angle to this. So you might be wondering how we're going to figure out a wind correction angle. Well, there's multiple ways you could do this. One is you go online, you could find a calculator that does this. Sky Vector, I think, also does this. Maybe, I'm not sure. I think it does. Or you could use a electronic E6B, or you could use one of these things, which is a old school style E6B. And I wish they were phased out by now, but unfortunately they're still using it during primary flight training. And so here we are using one of these slide rule type things. Anyway, so I guess I should give a little background on the E6B. So the E6B is an electronic flight computer, or not electronic, a flight computer that has been used for forever and has two sides to it. It has the front side and it has this back side. So it has this front side, which can do calculations. It can do a lot of different things. It can do time distance calculations. It can do conversion calculations. It can do multiplication. It can do division. It can do a lot of stuff. I don't even know the full extent of what it can do. Anyway, there's a lot of stuff it can do. It's basically a fancy slide rule. And this inner part rotates. And then you get your answers by comparing the inner and outer rings. It also has some other windows here, which you can use. Then on the back side here, we have our wind side. So basically you have this piece which rotates up or slides up and down. Then you have this inner piece which rotates around. And then we can use those two to get our wind correction angles and other stuff. So we're going to be using this to compute what our wind correction angle is. And then we'll also use it to compute ground speed and stuff. So to use this, what do we need to do? So first off, we need to get our winds in here. So we're going to slide this down. You could put it anywhere you'd like. However, I find that it's easy to put it at 100 because then you can just add whatever your wind speed is to 100 and it's pretty easy to get it close on here. So we have a wind speed of 7 and a wind direction of 350. So what we need to do is we need to put our wind direction at the top where it says true index there. So we're going to rotate this wheel. We're going to put 350 at the true index. So that's our wind direction. Then we're going to put the wind velocity 7 knots up from 100. So that's a 7 knot increase from 0. If you think about 100 is 0. And so we're just kind of going to guesstimate here. It's somewhere around there. So somewhere in there is about 7. It's close enough. It's best you can do with these things anyway. So 350 at 7 is going to be our winds. Next, what we have to do is we have to put in our heading. So our course route is going to be 7 degrees. So we'll rotate this over to 7 degrees. So now we have our heading in there. And now we need to move this little dot that we put earlier for our winds up to our true airspeed. So what we'll do is we'll slide this top part up until we hit this line where our true airspeed is, which is 115. So that goes out like that. And so once we hit that, that'll be where we'll stop. Now, there's two things that we can read from this. One, we can read our ground speed, which is underneath this centerpiece, which is sometimes a grommet on the actual physical ones, and this is just a little circle. So that centerpiece here is where our ground speed is going to be. And then up here, where this dot is, it's going to be on a vertical line, and those vertical lines represent our wind correction angle. And so what we're going to do is we're going to take our wind correction angle, and we're going to either add or subtract it from our true course. And so, or we're going to add or subtract it to our course heading, and then we're going to get our true course. So in this case, we are on the left, and so we're going to subtract our degrees. So this is about 1 degree off. You can see that this bold line here is 5 degrees. So 5, 4, 3, 2, 1. So we're about 1 degree off of a wind correction angle. And so we can go over here to our nav log and we can put in here for our correction is going to be -1 degree. And again, the other thing we can read here is our ground speed. And so we can see that if we're flying at 115 knots, our ground speed is probably going to be about 107 knots. So we can go over here also, and we have this ground speed box. And we can put, for our ground speed, 107 knots. That'll be our estimated, and when we actually fly this route, we can calculate our actual and see how close they are, and that'll allow us to do fuel burn calculations and see how close we are, see if we need more gas, less gas, whatever. Actually, you could probably never have less gas, but it's always better to have more. So you can see how much fuel you're burning, and we'll check those numbers later. So for now, we'll put that under the ground speed column, and I'll put it in our estimated box. So those are the two numbers that you need from here. That's how you calculate those. The next thing we need is we need to figure out our true heading. So this we can get from our map. What we need to do is we need to get a east and west variation. And what this is because there's a difference between the true pole and the magnetic pole, we need to figure out that difference in magnetic pull, basically. So way to do that is we have to use isogonic lines, and these isogonic lines are presented by these dashed magenta lines here on the sectional chart, and it has a degree and then a direction. And you can find these, there's other ones out here. Here's another one, and you have to go down till you find the number on them. Here's 7 degrees west. Where did our line go? Here it is 6 degrees west, and then they go down to 0, and then they start back going east. And so we need to take this number that's closest to our route. So in this case, it's almost right on our route. Doesn't quite intersect our route, but we'll pick the one that's closest. So 6 degrees is probably closest, and we'll have to either add or subtract this number. And so in this case, we're west, and so we'll add 6 degrees to our corrected heading here. Let me real quick just carry these numbers over. So we're flying 7 degrees. Minus 1 is 6 degrees. And then we'll put our variation in here. So 6 degrees west. So we'll put add 6 in there. And then we'll carry those over. So 12. So we'll add 6. I don't remember where the 0 line is, but it's somewhere over in this area. There's a 0 line. Here's 1 degree east. This must be 0. So here's 0 degrees. So it runs kind of through like Minnesota and Iowa maybe. But we're over here. So we get our westerly variations. And so we carry those numbers over. So we've done our wind correction angle, we've done our variation, and now we have to input our deviation. And our deviation is something we have to get from our aircraft. So our compass sits on the dash in 172 or up in the top. And when it's inside the airplane like that, and it's around electronic equipment and radios and stuff like that, it has a certain pull to it. And so the aircraft pulls that magnet that floats in the little cylinder thing. And we need to know what that amount is so we can correct for that. And so usually this is something that's done by a mechanic, and they calibrate it and they go out to a special place and they know exactly which way is north and whatever. And they calibrate it. And then they give you numbers, which is known as the magnetic deviation. And so what you can do is you can take those numbers from your aircraft's handbook, or it's usually on a placard on the compass itself. And then you would either add or subtract that to here. It's usually a very small amount. But for our case, we'll consider that it's perfect and that we do not add anything to that for our deviation. And so we finally end up with our compass heading, which we will use to navigate inside the airplane. And so we'll put 12 in there, and that is what we'll use to fly this route. And this adjusts for winds, it adjusts for our isogonic line, and it adjusts for our magnetic error in our compass. All right, now we can compute our times. So we have to know our distance. And like I said, you would use a plotter, but We don't have plotters on here, so we can just read it off of this line. So the distance from Grand Rapids to Big Rapids is going to be 51 nautical miles. And so that is not what we want to put in here. What we want to put in here is our distance between our checkpoints. Our total distance will be 51. However, our actual distance between legs will not be. So what we can do is we can go up here to our flight plan and we can add checkpoints. Put this GPS coordinate in there, and we'll put, oops, cancel. And we will put that GPS checkpoint in there. And that way we can kind of get a rough estimate of how far is between legs. So from Grand Rapids to Cedar Springs, it looks like it's about 21 nautical miles. So we can go in here and we can put in our 21 nautical miles. And then from Cedar Springs to Howard City, it looks like it's another 11 nautical miles. And then, oops, I forgot to put the ending airport, Robin Hood. Just pretend that these numbers are all copied down. It is another 19 nautical miles. So now that we have our distances, we can go ahead and we can calculate times between our legs so that we know how much fuel we need. So the first thing we have to do is we have to copy the ground speed here. Is we have to use our E6P again, except this time we're going to use the front instead of the back. And so we need to calculate how long it's going to take us, given a certain airspeed, to go a certain distance. And so the way we do this, and most E6Bs also have this on the front in case you ever forget, is we need to use this little triangle, which is the rate triangle here. And we're going to put that at our airspeed. So in this case, we're going to rotate this inner wheel over, and then on the outer side, we're going to put it at our airspeed. So we're going to be flying at 115, and so we're going to rotate this to 115. And we'll put our rate right there. And so our rate, 115. The next thing we need to do is we need to then look at our distance that we're going to be traveling. So for our first leg, we're going to be traveling 21 nautical miles. And then we can go over here and we can look at our distance on the outer wheel. So we'll go over here to 21, which I don't think I could rotate this. It's kind of hard to read. You can kind of read it sideways here, but so we'll go to 21, and then we'll read on the inner wheel how long it's going to take. So it looks like it's going to take us about 11 minutes. So you can go back to our, oops, over here, and we can put 11 minutes in for our time. Now, if we wanted to check this, you could use electronic calculator, but this is pretty close to the real numbers. So, and then we can do this for the other ones as well. So we can go 11 nautical miles. So we'll go on the outer wheel and we'll go up to 11, and we can go down, and looks like it's probably gonna be about 5.6. You kind of have to move the decimal around in your head when you're reading this wheel. But it does work. So yeah, it's about 5.6, 5.7. So, you know, if you want to round up, you can. We'll round up just to be safe. So it's probably about 6 minutes. That's going to take us to do that route. And that makes sense. That's about half of the one above. So, and then our last leg is going to be 19 nautical miles. So we'll go over here 19, and that's almost 10 minutes. It's pretty close. So we'll go with 10 minutes. If you want, you get more exact, you can put decimals and stuff, but E6B is only as exact as you can read lines. So do whatever you want with that. So we have our times en route now. So 11, 6, and 10. And now we need to calculate our fuel burn for those legs. So we can again go over here and we can use this rate symbol and we can put it on our fuel burn, which for our purposes, we're going to use 10 gallons an hour. And this is another number you can look up in Pilot's Operating Handbook for the aircraft. But for a Cessna 172, it's around 10 gallons per hour. So over here, we'll put the rate at 10. So that's our fuel burn. And then we're going to look at our time en route. So it's going to be 11 minutes. And then we're going to go look in here and we're going to put our time on the inner circle. So 11. And then we're going to read our total gallons on the outer circle. So 11, and that looks like it's probably going to be about 1.82 or something. We'll go with 1.8 as our fuel. And again, you have to move those decimals around in your head kind of. It seems more likely it's going to be 1.8 gallons rather than 18 gallons. So yeah, anyway. Next, we're going to look at 6. So we're going to go in here, we're going to find 6. And that happens to be right at the top here. So there's not actually going to be a 6, but you have to imagine the 60 is a 6. And it looks like at 6 minutes, we're going to be burning about a gallon of gas. And then lastly, we have 10. And we can go over here and we can see it's almost 1.7. Better to err on the side of caution to have more gas. So we'll go with 1.7 for that. So now we have our fuel burn and we can calculate our total fuel and we can calculate our total time and our total distance. And we can add all those up. If you want to put an actual time in here, you can put a time in here and you can figure out the exact time that you would arrive given this wind situation. But we're not going to do that for this flight plan. The other stuff you can fill in here is you can fill in like fuel elevations and like frequencies and stuff like that. In fact, why don't we do that here? We have a little bit of time. So our departure airport is going to be Grand Rapids, and we'll put the symbol in here. So KGRR, and our landing airport is going to be Robin Hood, KRQB. Field elevation. So field elevation at Grand Rapids, you can read from their little airport box again. So down here, it's going to be this number, 794 feet. So you can put that in here. We can use that to, again, check our altimeter or get fuel elevation if we don't have an altimeter for some reason, but Grand Rapids has an ATIS, so we can get that, the pressure information from them. But Robin Hood, I don't think they have. Yeah, no, they don't have. Well, they do have an AWAS, so you could get it from them. But we'll also put their fuel elevation in here. This also helps with pattern altitude. So when you're flying a pattern altitude, you want to be 1,000 feet above the airport. And so knowing what their elevation is, you can pretty easily calculate what that number is. So at Grand Rapids, you probably want to be at 1,800 feet. And at Robin Hood, you would want to be at like 19 or 2,000 feet probably for that. So we'll put in 990 here. And then go down here. ATIS information. So Grand Rapids does have an ATIS. So you can find that frequency after it says ATIS. So 118.725 is going to be that. You can also look it up online and in the chart supplement as well. Grand Rapids does have a ground frequency. This is something you'd have to look up online, but I'm pretty sure it's 121.8. They also have a tower frequency, which you can read that from a sectional chart. So it's over here, and that's the CT-1 and then the number. So 135.65, and that's going to be our tower frequency. They have a departure frequency as well, which this is again something you have to look up. It's not necessarily on the chart. I did have a section, I had a chart supplement, but I don't remember where I put it. Anyway, I think Grand Rapids, they have two departure frequencies actually. They have a north and a south. And I believe that the north one is 124.6 maybe. I might be wrong on that. I don't know. We'll just go with it. But I think that might be right. I'm not sure. So those are the frequencies that we would need, but you can fill those in as needed, or other frequencies if you need them. We're not going to use a control frequency. So yeah. Now Robin Hood's not a controlled airport, so for this we'll use their CTAF, and that is going to be 122.8. So that's that number there, and it has a little C indicating that is the CTAF. So we'll put 122.8, and that is what we'll use to communicate with other pilots in the pattern at Robin Hood. So now we've kind of filled in all of this information, and I'll go ahead and fill this across here. And in fact, if you wanted to see if this would work, and you had access to a flight simulator, you could set it up so that it has all this correct information and all the winds are correct. And you could fly this route from Grand Rapids to Robin Hood and use the numbers calculated here, and you should end up right on course. And in fact, you could do this for any number of scenarios, for any winds, any elevations. You just have to use the right numbers, and it should work out. Now, here in a second, maybe I can show you how easy it is to use SkyVector to do this and check your work. Let's put in our altitude here, 5,500 feet. And fuel, we're gonna have, I don't know, let's say 40 gallons on board. It's not a ton, but so yeah, so no go nav log, and we'll generate our little nav log here. So this nav log has basically everything that this does, and it's calculated it for us. They came up with slightly different numbers than we did, but it's pretty close. So they also had some other checkpoints in here. So they have a top of climb and a top of descent, which are checkpoints used to when you reach the top of your climb out of an airport, and when you start your descent into an airport. You could add those as well. Let's see, they use slightly different winds, it looks like, than what we have, because when you're lower, you have different wind speeds, but we just kind of calculated 350 for everything. Looks like they calculated it 336, but that's whatever. So yeah, they used slightly different winds than we did, but that's why they ended up with a slightly different heading. And then yeah, everything else looks about the same. So you got pretty close on the distance. I think they divided it up again a little bit differently, so it's hard to say, but yeah, so this is pretty easy to do electronically, but unfortunately we can't do it that way in training, because the FAA apparently wants to know that you can do it this way for some reason. So yeah. So any questions overall about any of this flight planning, any of the numbers I used, any of the calculations, how to use an E6B, anything like that? All right. So yeah, so that's VFR flight planning in a nutshell. There's a lot more that you could do with it. You could plan various routes. You could zigzag between airports. You could do different headings. different altitudes. Yeah, there's a lot of things you could do. So I don't think I'm going to spend a ton more time on this aspect of things. I might go over it again maybe at some point in the future. But this is kind of one of those things that is best learned through practice. So one of the things I would recommend is maybe just going to SkyVector and just playing around with the routes, and then doing the calculations on E6B. If you don't have an E6B, you can use one of these ones. This one's from University of North Dakota. There's other various interactive ones out there that you can use to do calculations. They also do make electronic E6Bs, which you can use on the FAA tests, as far as I'm aware. They do allow you a calculator, I think, and a E6B, either electronic or a manual one on the written. And so you can use that, and you can practice making those calculations. E6Bs have, again, the how you do the miles per hour and the gallons per hour down here. So if you forget, those are there. And also on this, it tells you how to do the wind correction angle and to get the ground speed and such up here. So yeah, I don't think, let's see, what's next after flight planning? I think next we'll probably move into some aircraft performance and weight and balance stuff. And we'll try and get through that. However, next week being finals week, I don't know if we'll meet or not. We'll probably not meet during break either. So I'll make that decision later. I'll plan for not meeting next week, and we'll just kind of wait until after break. So next meeting would be sometime in January, I guess. And it might be on a different day, unfortunately. I'm not sure what days will work best yet. I kind of have to figure that out, but I don't know if Mondays are going to work anymore. So hopefully that doesn't conflict too much with any of your schedules, but we'll see when we get there. So yeah, we only have, let's see, we've covered weather, we've covered charts and flight planning, FARs. So we've covered a lot of the big sections. So now pretty much all we have to do is we have to go through and do like aircraft building or aircraft structures, what aircraft are made of, different components of aircraft, aircraft performance, aeronautical decision making. There's a few other sections we have to do, but overall, there's not a ton. It's not a lot of content. It's probably similar in scope to what we've covered so far. So yeah, so hopefully we'll end sometime next semester. Not sure when though. We'll get through all the materials. So yeah, that's where we are thus far. And again, if you have any questions with doing this flight planning stuff, feel free to ask me, and I'll be happy to help.
So one thing that just occurred